Another topic related to decimals are what we call the decimals and equivalent fractions. So here's a long list of fractions that at some point I think in your use you'll start to memorize that these fractions have these decimal equivalents. And these are interesting fractions because when we encounter them we can use them, or when we encounter the decimal equivalents we can use them to do calculations. Again, here are the answers already so you can take a look, but I just want to make sure I talk through a few of them here. When you think about how would I do it, like most of us will panic and say, I can't do 68 times 0.5. I mean, I have to like write it all out. But if you know it's decimal equivalent, 0.5 is 1/2, you know, oh, I'm just taking half of 68. And so one way to solve decimal problems is to convert those decimals or round to those decimal problems to its nearest equivalent fraction. This is 1/4, 1/4 of 48. 0.2, you will see, is 1/5. And so you can see I would just divide this by 5. 0.05 is 1/20th, and so then you divide that by 20. So that's the idea on these equivalent fractions, is to convert these decimals to its equivalent fraction. Be aware of those and then use fraction arithmetic to get your answer, which is sometimes easier because we're dividing by, right? When you're taking a half of, or a quarter of, or a fifth of, or an eighth of, right? This looks very hard to do in your head, like there's no way, but then we recognize that 1/8 is 0.125, right? And that just comes from use. Other things we can do is multiplying. There's when we multiply by powers of 10, we know there's a shortcut here, and you can see here's the long way to do it, 3.75 times 10 to the power 4. Now what we do is we convert this decimal to its equivalent fraction. 10 to the power 4 is 10,000 over 1, and then we can multiply, right? Same thing here. This is 62.013 times 10 to the power 5. Turn it into its fraction, right? This is thousands times 100,000, and then you can simplify, cross out how many zeros, add the zeros, you get your answer. So this is one way to think about it. But if you do this, as you do this work here, as you see how this gets calculated, you start to see a shortcut, right? And so all we learn is that when you multiply by a power of 10, right, that's equivalent to moving the decimal point to the right, right? Dividing by a power of 10 is equivalent to moving the decimal place to the left. And again, that comes out of this work here of doing it the long way, converting these to fractions, and then doing the mathematics on that. And then you recognize there is a pattern right here. 0.003 times 41,000. Again, you end up just moving the decimal so many times, right? You do 3 times 41 and then move the decimal. Something to consider. And then the last topic that many students struggle with is the rounding, right? And so we talked about this a little bit prior with whole numbers, but now we're looking round to the nearest tenth, right? And here are the answers to that. And again, a rounding is just an estimate. This is a number, and all we're doing is now we're trying to just come up with an estimate for this number to the tenth. And you go to the place value, and then everyone, again, when we're rounding to the nearest, you remember the rule is, so in this case here, to the nearest hundredth, which is 2 decimals. Since this is a 4, right, it's 94, right? It's closer to 90, and so that's where it's 0.9. Here, 943. And so then that's what we're looking, because we're going to 2 decimals, so it's 94. Now, when we're going to 3 decimal places, you'll see you have this 5 here. We'll turn this into a 4, and you'll get this round when it's 5 or above. That's that round up, 5 or more, right? And then to the 10,000, that's all of them here. Sorry, that's 4 decimals. That's a 2, so you just keep it. Again, this is just a rounding, remember, is just a way of estimating. And so we learned for decimals ending in 5, we can round up, use the round up method, right, as usually done in elementary school. And so you keep that in mind. And then here's just the last set of problems to look at too. Again, how would we in these problems estimate? Again, we're just estimating, and so estimating really is based off of, this is one way, estimating is really based off of you making it to a compatible number yourself. Is making it a compatible number yourself. And so that's where you want to look at these methods here, but there's a lot of different ways to estimate. It's based off of your compatibility, but these are just some of them. 30 and 2, 250. Make this 75 and make this a 0.25, right? Make that times, 0.25 to make sure we could do something like that. And so you're looking through these things here. That's it.